interlobar arteries. This, by the way, is an interlobar vein. You see that? Right here. Right here, interlobar vein. Here's an interlobar artery, right here and right here. Now, they outline the border between the renal cortex and the renal medulla. They outline the border. They form the border. You got that? Just right here. You see that? Renal cortex, renal medulla. Arcuate arteries and veins, interlobular. Right here, these are interlobular arteries. You see them? That means diminutive. What does diminutive mean?
Very small.
Very small, tiny, delicate, interlobular. Okay, all right. Now, these are Bowman's capsules. You see all these little white dots? Bowman's capsules. Notice the interlobular arteries divide into what? Afferent arterioles. They go into the Bowman's capsule and they exit as what? Efferent. Remember A before E. Now look here. Here is a glomerulus. This is a glomerulus. This whole thing right here. This is the Bowman's capsule. This is the glomerulus. The capillary network. You with me so far? All right. Here is a cortical nephron. Notice that it doesn't go nearly as deep as what? Juxtamedullary. They're not the same. Juxtamedullary goes much deeper into the medulla. Now, this is the proximal convoluted tubule. That's where all that water gets reabsorbed. Remember I told you 60 to 70%? About 117 liters. Okay? That's pretty close to about 38 gallons. 38 gallons of water. This is the proximal convoluted tubule. Well, have you learned the word proximal and distal? They both have reference to what? A point of origin. Did you notice that? When you studied them back in table 1.2 through 1.5, proximal and distal had reference to a point of origin. What's your point of origin? The Bowman's capsule. Proximal convoluted tubule, descending limb. What's this right down in here? Loop of Henle. By the way, Henle and Bowman were contemporaries. If you look at the footnotes that I made on both of them, you'll be able to see that they were born about the same time. They died about the same time. This is the ascending limb, and this is the distal convoluted tubule that connects to what? The collecting duct. Right here, we get the drip, 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 and it collects where?
The ureter.
In the renal pelvis, and spills over into what?
The ureter.
The ureter. There we go. But before the distal convoluted tubule, pay very careful attention. Before the distal convoluted tubule connects to the collecting duct, what does it do? It revisits the glomerulus, the area around the glomerulus. Do you see this? Do you see this right here? This right here is this right here. Proximal convoluted tubule. Right here. Do you see right here where I'm pointing? That's this structure right here. Do you know what this is? That's the distal convoluted tubule. Right here. There's a section of it. Now, if you look very closely, you will see the nature of these cells is not the same. Right here, what shape do they have? Do what? What shape do these cells? These cells are cuboidal. But when you get down here, what shape do they have? Columnar. This right here is your macula densa. Have I mentioned that before? Macula densa. This is your source of renin, angiotensinogenase. What's the other part of this juxtaglomerular apparatus we're talking about? Do you see this right here? That's the afferent arteriole. Look at all this rough structure right here, and this is a cutaway view. These are smooth muscle cells. What do? They exercise the two types of vasomotion, and what are they?
Constriction and dilation.
Vasoconstriction and vasodilation. They are under the direct influence of renin that's released from the macula densa to either go vasoconstriction or vasodilation for the purpose of controlling what?
Blood pressure.
Blood pressure / flow. Okay, blood pressure / flow. All right, what did I say this was? Glomerulus. What's this structure right here? Bowman's capsule. Now, do you remember my mentioning that in the proximal convoluted tubule, you recover about 65% of that 180 liters of glomerular filtrate?
Yes.
Do you see these stipple structures right here? You have to get in close to see this. That is your brush border. Have you ever heard of that before?
Yes.
Microvilli. They're located all along here. And sure enough, by the time you get to here, you've already recovered about 117 liters. Learn these models well. This is my favorite model for the lab practical. Here's a whole kidney. Renal pyramids. By the way, this is the pelvis. What's this?
Artery.
Renal artery.
Renal vein.
What are these?
Pyramids.
Renal pyramids. What's this right here? Interlobar
Vein.
vein. What are this? What's this right here?
Coronal artery.
Arcuate. Arcuate. What does arc mean? To curve. If you make an arc, you make a curve. Is that right? Okay. And what are these structures right here?
Interlobular veins.
Interlobular arteries.
Arteries.
Okay. Now, pay attention. Do you see these funnel-shaped structures? You've got some drawings in your class notes that show you these. This is called a calyx. It means horn or funnel-shaped. Okay, this is a minor calyx. Each individual calyx is a minor calyx. When you have more than one that combine, they make up what? 1 plus 1 is 2. Here's your third one. What do they make up? A major calyx. A single calyx is a minor calyx. A combination of 2 or more is called a major calyx. All right, now listen, I'm going to